Our first semester review, part 1. In order to review for the semester's worth of material, I'll only cover a few of the problems. Try working the rest out on your own. We will do problem number 1 from the unit 1. Which of the following sets of numbers is ordered from greatest to least? So here we have to figure out which ones have the numbers that start with the biggest numbers and go with the smaller numbers. So, and one way to do this is to compare them in the same unit, whether we're talking in all rational numbers, which is fractions, all percents, or all decimals. For me, I like decimals. So 1/3 is approximately 0.33. So if we see this is decimal 33 and this is decimal 35, since decimal 35 is bigger, this is not in order from the biggest to the least. Then let's look at this. 0.32 is 32%, and we've already stated that 1/3 is 0.33. Since that's bigger than 32%, we have to call that wrong. This is decimal 4 already in the decimal form. Decimal 33, I don't want to have to write it again. I have it right here. Decimal 25, and then decimal 1. It goes from decimal 4, decimal 33, decimal 2, decimal 1 does go from greatest to least. Let's check the last one just in case. D-state starts with a negative number and goes to positive numbers. We see that this one, if you really look at it, is going from least to greatest. So D is not correct. Again, one of the better ways to compare numbers is to put them into the same form. C is the correct choice. Let's look at problem number 4. Problem number 4 reminds us of how to do scientific notation. Here we have something in scientific notation, and we want to put it into standard notation. So we start out with the values, 3.8. And since our value is a -4, we know that our number is going to be very, very small. So what we're really wanting to do is we're wanting to take this decimal place that's right here, and we want to move it over 4 spaces to the left to make it a smaller number. Move it over 1, 2, 3, and 4. Our decimal place should be now right here. Well, we don't have anything in here, so what we need to do is we need to put zeros as a placeholder. Well, in our value here, we see that we have 3 zeros before our 3. So in this case, G must be right. If our number had a positive exponent, we would have been moving the decimal to the other way to make it a bigger number. Let's look at number 1 on our second section. I believe this is the 4th page in your review. We're going to start with reading the question. It says, which equation below would she use to determine how many hours H she must babysit before she can buy the jacket? So here what we're going to need to do is to look at some information. First of all, we know that her jacket costs $200. She starts with $50 in her savings, and then she earns $7 every hour, per hour, each hour. Remember, this right here tells us that we're going to multiply 7 times the number of hours that she babysits in order to find out how much money she gets for her babysitting. So when we look down, we see that A does not multiply 7 times H, so it can't be there. Well, in addition to the $7 an hour, she already has $50 in there. So in order to when she puts that money in her bank, she's going to add them together. So B won't work since she's subtracting $50. And D won't work because that's subtracting 7H. So the correct expression for her equation would be C. To make the $200, she's got $50 plus her babysitting money, which is $7 an hour. Let's look at number 5. Going a little bit crazy on us here. Okay, it states that Lincoln Middle School has canned food drive. 6th graders brought in 5 3/4 boxes of canned food. The 7th graders brought in 6 1/2 boxes of canned food. And the 8th graders brought in 7 1/3 boxes of canned food. What was the total number of boxes of canned food brought in by the 3 grades? Now, this is an equation that we're basically going to want to be adding these together. But how do you add values that have different terms? We have 2 that are in decimals and 1 that's in a fraction. Well, the first thing we need to look at is what form our answer choices are in. If we don't have any answer choices, then it really doesn't matter. We could choose what we like. But as we can see here, what we need to be doing is you need to add them as fractions. So what we're going to do is we're going to change all of these to fractions, particularly mixed fractions. So we're going to start with the 6th graders. They brought 5. Decimal 75 is 3/4, so it's 5 3/4. And we're going to add what the 7th graders did, which is 6 1/2. Then we're going to add what the 8th graders, which should win because they're 8th graders, is 7 1/3. Now we have to add all these together. Adding the whole numbers usually won't be a problem. We could simply add 5 plus 6 is 11, and 7 is 18. But when we add 3/4, 1/2, and 1/3 together, we see that they don't have common denominators. So we have to figure out what the common denominator is between 2, 3, and 4. Well, the common denominator between 2, 3, and 4 is 12ths, which gives us a little hint here. We need to change them all to 12ths anyway, since every answer choice is 12ths. So in order to get 3/4 into something 12ths, we have to multiply the numerator and the denominator by 3, because 4 times 3 is 12. So 3 times 3 is 9. If I want 12 in the denominator of this one, I'd have to multiply the denominator by 6. So I also multiply the numerator by 6, and I get 6/12. And in order to multiply this one, but get to 12 in the denominator, I have to multiply the denominator by 13. By 4. 4 times 1 is 4. Now we add the fractions. Now remember, when you're adding fractions, that the denominator does not change. So it's going to remain 12. So here we have 9 plus 6 is 15, plus 4 is 19. Now we all know that 19 is bigger than 12. So we have to split this up. That's the same as 12/12 plus 7/12, or 1 7/12. So if we add 1 7/12 to 18, we get 19 7/12. D is the correct solution.